Oh, thank you, Addy, for the introduction. So like you said, I want to talk to you about JavaScript tools today, and specifically how you can use type information to help scale your code base. Because as you add more lines of code and more developers to it, there's certain areas where it becomes harder to maintain and harder to keep evolving and changing your code base. So my name is Mark, and I'm a software engineer at Google. And this is the number of lines of JavaScript code at Google since 2009. And it's up and to the right and growing at a pretty fast pace. We are adding the size of our code base at 2010 multiple times a year now. And the number of developers are also growing at that same, a little bit frightening pace. And with this, we have one single large code base at Google and a lot of developers. And so at some point, this becomes harder to maintain. It becomes harder to change your code base and keep a high quality bar. And so myself and a few other collaborators at Google, we spent some time trying to figure out what can we do to help alleviate this problem? What can we do to make it easier to keep growing the code base? So one example challenge of something that's hard to do is if you just wanted to rename a function, right? It's just you have a class and you define the function on it. It has a very generic name to it. But because your code base is so large, you have 50 other classes that have that exact same name. How do you actually differentiate between, in a piece of code, differentiate between two objects of different types when you just want to rename one of those functions but not the other one? And this and other problems that arise, to help fix these, we worked on two tools specifically. So the first one is called RefasterJS. And it's a tool to make refactoring easy. So all of the excuses that a developer can come up with for why it's hard to change a piece of code, like there's too many people depending on it, it's impossible to fix all of those code to change it. This tool should make all of those go away. And the second thing is we call JSConf, which is a way to prevent bad code from creeping back into your code base. And this is a tool that really helps developers and your project keep a very high code quality bar because no matter who's reviewing or submitting the code, you can make sure to prevent bad code from entering your code base. And to tie everything together, I want to use a running example, which is really important to web apps today, which is how do you eliminate XSS issues in your project? And so an XSS can be really costly to the user, losing user data, and to your company with lawsuits, breach of user privacy, and so forth. And so using RefasterJS and show how you can fix existing bad XSS vulnerabilities and how JSConf can prevent them from coming back again into your code base. And so this example is actually based on something that the security team at Google has worked on over the last year, which is something they call API hardening inside of Google. But specific to the web, they worked on a library called GooDOM Safe, which is safe wrappers around the DOM API. The DOM API has a lot of security holes. A lot of people know about common ones like inner HTML, not sanitizing the HTML that you pass to it, outer HTML, eval, and a lesser known one, but still equally important, is if you assign to the href of window.location and the input is user controlled, they can actually execute arbitrary JavaScript code. And if they're evil, they can execute code that steals user data and so forth. And so with a very, very tiny change that anyone could implement, you can rewrite that to use a safe set location href function, and this would sanitize the input so that no attack is actually executed. A colleague of mine on the security team actually published an article in the ACM about this that goes into more detail about the overall effort and the other APIs. So it's definitely a very interesting read. So to dive in, the first tool that I want to talk about is RefasterJS. And this is a tool where you write JavaScript to refactor JavaScript. We're all JavaScript developers, and we shouldn't have to write another language or learn something new to try to change a piece of code. We should be able to write what we want the code to look like, and then something should make that happen. And its core additional tenet is that it leverages type information to pinpoint the code that you want to change so that it's not matching too much, not matching too little, but matching just the piece of code that you want. And we run this at Google across Google's entire JavaScript code base. And so it was designed from the beginning to make sure to run in just a matter of minutes across large sets of code. And the core piece of thing that you need to provide RefasterJS is just a JavaScript file. And it looks a little bit like this. And there's two functions that you provide to the RefasterJS tool. If you notice, these tools are based on the Closure compiler, which is an open source JavaScript compiler from Google, which the main thing that it's known for in the open source community is the ability to process type information and store it and use it at a later time to do type checking and type-based optimizations. And so if you're familiar with that, you're familiar with the type annotation syntax, which provides the compiler what type these objects are. But the first half of the template shows what code should be matched. And so this is really the finding algorithm, so that if you pass 100 source files, it knows which specific statements are the ones that you want to target. And the second thing is then, once you have those matches, how do you apply a fix? How do you transform the code? What should it look like? In this case, we want to match any direct assignments to location.href and transform it to use the goog.dom.safe library. And so looking at the matching code, it looks a little bit like this. And this will match the direct assignment, where you have the left-hand side window.location.href equals some string. But also, it will match if you alias the window location object to a local variable and still assign the href property of that. And on the right-hand side, you have a function that returns a string. It still knows how to match that. But it won't match if you just have an object literal where you're assigning to an href property of the object literal, because that's not of the correct type. And so this is where the type information comes into play, because it knows how to differentiate between all of these use cases. So how does it do this? Well, the first thing it needs to do is build an AST, which is an abstract syntax tree. And without going into too much detail, it's just how does a compiler represent a piece of code? And as you see here, on the left-hand side is kind of the node structure of the AST. So you see there's an assignment, the equal sign, and then there's a left-hand side, which is accessing a property, and the right-hand side, which is just referencing a variable. And on the right-hand side of the slide, you can see it highlighted that this AST preserves type information, whereas a lot of other ASTs for JavaScript don't preserve this information because they don't know how to infer the type information for a piece of code. And so looking at a quick demo, there's a web service tool where we can look that the compiler team provides, where we can store a piece of code here. Zooming is not working super well. And then on the right-hand side, when we compile this, we can see what the AST looks like. And this is exactly the same as what you see on the slides. In this case, we also have the variable declarations for storing the URL and the location object into local variables. And you see here, it knows the type information at every single point in this AST, whether it's a string, a window object, or a location object. And that's a nifty tool if you just want to play around and see what the Closure compiler is doing and see how it impacts what the AST looks like and what the types look like. Once you have this, then the tool needs to compare AST structures from the template against the source code. And there's a lot of different ways to do this depending on the accuracy of the matches and what you have available to it. So the first approach, kind of a naive approach, is to just match what the node structure looks like. And in this case, you just take the left-hand side, which is kind of the structure of the code, and make sure that those match. And noticeably, if you change one node in it, say you change it from a variable to a string literal, then it won't match anymore. And so this will match things like location.href equals a URL. It will also match some random object where you reference a name property and some string, because it has the same structure, even though the types and the names of the objects are different. And also, unfortunately, it won't match something like location.href equals a string literal because they have different structures. And so you can improve this a little bit. You can use the node structure and the name of the variables. But again, if you do that, then changing one of the two, whether it's the structure or the variable name, causes it to break. And so this will match, if you alias LOC, window.location to the LOC variable, it will match that. But it will also match it if you just have a normal object literal, and it won't match another case where you change the variable name. So this is still not really what we want because it's not accurate enough. And that's where RefasterJS, we get to this last matching, which is it uses either the node name and structure or the JavaScript type. And this is where the type comes in handy to be able to have the flexibility to match different pieces of code. And so at every level in this AST, you can see it's either matching on one side, the left-hand side, or the right-hand side, but it doesn't have to match both. And the way it knows which one it needs to match is you told it. In the template, you told it which are the types, which are the wildcard types, and which actually have to be the exact same thing. Like the href property has to be href. And so here, you see that the boxes correspond. These ASTs are different, but they resolve to the same type. And this is OK. This is what RefasterJS matches against. And so with this, we get matching the alias case, where we have loc.href equals URL, or we have the full thing, window.location.href equals some function call. And we also don't get if you just have an object literal and assign a property on that because it's of a different type. So this is looking pretty good. This will match the right set of code. Once we have that, then we need to take this code and transform it to what the code we want it to look like. And so this function looks very similar to the before case, the matching case, except the body of the function corresponds to what you want the code to look like. In this case, we just want it to use the setLocationHref function. And so it would take an example like the top piece of code and then transform it to something like the bottom piece of code, where it preserves the names and code structure because the tool doesn't care about any of that. So you can alias window.location to whatever name you feel like, and it would still preserve the right piece of code. And it does this because of this matching by type. It knows that in the template, the LOC variable should be replaced by the source code that it matched against from the same type. And so it can preserve that code structure and names. And so taking a look at a demo, back to the handy web service page, we can see down here that the template, you can enter in this page the template exactly as it looks on the slide. So this is exactly the same as what I had on the slides, including matching the direct assignment and transforming it to GUG-DOM safe. And then you can see up top that I've input a lot of sample code following different JavaScript constructs that you might have in a real code base, whether it's a direct assignment, whether you're aliasing local variables, whether you're assigning it to functions, whatever it may be. And then when I hit this button and run, I can then see what the tool would transform the code to look like. And so here, I can zoom in a little bit. Here I can see that it transformed each of the statements on the left-hand side that we want to the corresponding GUG-DOM safe setLocationHref function, preserving the code structure, whether it's using a string, a variable name, a function call, or even accepting function parameters and preserving that as well. But again, because it understands type information, it doesn't match when you just have something that's not of type location, like an object literal. And so this is a pretty handy tool because it can also show you how you can debug this. If you have closure compiler warnings in the code, say the code isn't formatted correctly or it doesn't know certain types. And it also shows you at the bottom the ASTs of both the template and the source code. And so if something's not looking correctly, you can compare these against each other and see that whether they should or should not match based on the type information and the node names. So like I said, this was designed to run across large code bases, and if your code is large enough where it's prohibitive to run it sequentially across your source files, you can run it as part of a map reduce, which we do at Google, and in a matter of seconds or minutes, run it across hundreds, thousands, tens of thousands, millions of files in just a very short amount of time. In addition to fixing XSS vulnerabilities, which is a very important thing to do for your project, another use case is how can you keep evolving your code base? And so as your code grows, more and more people are depending on core libraries and APIs. And it becomes harder and harder to change these. If you wrote a piece of code 5 years ago, it may be crufty. You may want to change the type signature. You may want to change how people use it. You may want to migrate them to something else. And it just becomes harder and harder. And so the RefasterJS tool can be used to make sure that all the excuses engineers have for not modifying and updating code are eliminated, and they can refactor APIs and constantly evolve their code base and holding it to the highest quality standard and making sure that the APIs are as robust and as nice to use as possible. And this is how we refactor the core libraries inside of Google for JavaScript. It's tremendously useful. So a common question that burns on people's mind is, well, I don't use type information. Is this of any use to me? And there's good and bad news with this. Yes, it can be useful, but at the same time, the compiler might not have all of the information that it needs, and so you may get unexpected results. And so opening this demo, you can see on this right-hand side, I have a function where I take an anchor element and assign the href property of that to some URL. Right? And so in the specific example that I gave before, this shouldn't match because you have an anchor tag and not a location element or a location object. But unfortunately, because there's no type information here, RefasterJS does transform this. And so you get a lot of false positives in this case. The good news is that the Clojure compiler team does a lot of work trying to improve type inference, and they're working on it all the time. And they have a major change that's coming out over the next few months, which will actually keep improving how much type information can be inferred. So the compiler runs a series of passes that take information it already knows, like how do you call a function, what variables how do you construct objects, and then tries to infer the rest of your code, the types of the rest of your code, so that you don't have to explicitly type it. And so, constantly trying to improve this, the RefasterJS tool and the Clojure compiler itself can become more and more useful for projects that don't use type annotations. So now that you fix the existing usages in your code, you want to make sure that people don't introduce new ones, right? Because every new one would be a new XSS vulnerability and something that your project, you don't want to be submitted into your project. And so as your project grows and as your company grows, it's not really feasible to make sure that someone keeps an eye of all of the code being checked in your code base. And using the JS Conformance Framework, you can help make sure that becomes programmatic and automatic as part of your build or compile step so that they never get submitted in the first place. So with a few lines of code that you pass as a configuration object to the Clojure compiler, you can prevent this from this direct assignment of location href ever coming back, and the user would get a nice compiler error saying, this is not allowed. This is a violation that you're not allowed to directly assign to location href, but use goo.dom.safe instead. And so with this, then the developer knows that they have to go back and fix their code, and you've avoided the checking in the XSS hole to begin with, or whether it's something else that you want if you're refactoring APIs or so forth. So breaking down this configuration, the first thing that you want to provide to it is the type of the conformance. And here we're using a banned property right, which means that we want to ban people from directly assigning to a specific property. But there's a lot of other different conformance types that the compiler provides, and each one is meant to target a specific idiom that JavaScript developers use every day, whether it's referencing a property, writing or reading a property, calling a function, and so forth. And so as another example, you can ban eval just by saying ban name and specifying eval as the value. More complicated, you can use the RefasterJS syntax to provide a much more flexible configuration for the compiler that matches more complex code statements. And so if there's something more complicated than just banning a property or a function call, then you can use this syntax exactly the same as RefasterJS to create the conformance configuration as well. The second thing you need to do is just provide which value you want to ban. And so this depends on the type. In this case, because we're banning property rights, we want to ban anything that's assigned to location prototype href. But it can be any object or any property name that you want in your entire code base. Third, you want to provide a nice error message. So this is what developers would see when they get a violation. And you want it to be both informative and telling the developer why it's not allowed and also what they can use instead, so that when they see this, they go, oh, OK, I just have to go back, make a quick change it to use GDOM safe instead. And lastly, you can also use a whitelist. And this is, say, if you have an approved usage of the code. This directory has been approved by the security team because it's been heavily audited, then this directory won't, or this file won't be warned upon when the compiler checks the code. So going back to the handy debugger page that we were at earlier, there's a box here if you want to try this out that contains the conformance configuration. So here you can see that this configuration is exactly the same as what you saw on the slides earlier. And then you can, again, go up to this box here and insert some JavaScript and whatever you want to test. When you hit compile, you can see here that the compiler in this warning box shows you the violation. If I change the piece of code to say, again, I want to change the type, right? So if I alias window.location to a local variable and hit recompile, just like RefasterJS, it knows the code structure and the type information, and it knows that this statement is still not allowed, even if you alias local variables, call a function, do whatever magic you want. The compiler, because it understands type information, is able to warn. And only warn on the cases where it's actually a violation. So just like RefasterJS, there's a number of other possibilities that you can do with this tool. It's very similar to a lot that you can do with, say, eslint, but because it knows type information, you can take it one step further and start banning more different problems that you find in your code base, such as banning all of these XSS vulnerabilities, including eval inner HTML, outer HTML, document write, location.href, and so forth. You can also use it as part of a core libraries team to, say, restrict deprecated API calls. If you're trying to migrate your code base from one API to another API, then you want to prevent people from using the old one as you migrate. And so one instance, if you want to migrate your code base to promises, then banning your old async primitive, like deferreds or whatever else it might be, would be a good use of the JS Conformance Framework. And lastly, you can also specify any team or project-specific concerns that you have because the framework is flexible. So all of these tools are now available open source on the Clojure Compiler GitHub page. And I hope that Uh-oh. Computer's a little freaking out. OK. So these tools are available open source. All of the debugging pages I showed are available online also. And so you can use them to take a look at all of the tools and see whether they may be useful. But I hope that by trying to utilize type information that you can take I'm just going to, there we go. That you can try to take your code base one step further and make sure that it scales as it grows with the number of developers and the number of lines of code to make sure that you can keep it the most secure, performant, and highest code quality code base that you can. And so please take a look and please provide feedback. Definitely interested in hearing how it can be used externally. Thank you.